Welcome to Eclipse 2017, August 21st. This is an exciting event here for people in Northern Illinois and the college. We're going to have about 85% of our sun covered in the afternoon of August 21st. I waited for this for 20 years. My name is Paul Hamill. I've been teaching MCC for 20 years, and I've been waiting patiently for this eclipse for 20 years. I teach meteorology astronomy classes, and just to give you a little heads up, unfortunately I'm not going to be here. And I feel really badly about that, but I'm going down to actually see the full eclipse. So somewhere in the United States there'll be hopefully a clear spot where I can go and watch the full extent of the solar eclipse. So just real quick, let me explain what is happening and why we're having the solar eclipse. When you look at the sun is out there, and during a new moon, when a new moon occurs, what you get is in this diagram here, you have the moon and the sun will be to the left and the Earth's off to the right. Well, the moon isn't that big, so the moon can't block out the entire sun. So what happens here is this. In this diagram, you'll see the moon creating a shadow on the Earth. But the important thing to understand is this. When this eclipse happens, not everyone's going to see it equally. Some get it, some don't. And here's how it works. If you can see in this whole shadow region, when the eclipse happens on August 21st, anybody within this shadow will see the eclipse, but not all of it, because you can see the middle part here is a darkened region, which we call the umbro shadow. In the umbro region, that's what you really want to see, because you want to see totality. That's what I'm going to see. Several people at the college are going as well. I've talked to several students, and we're going to drive south to actually see the event, hopefully cloud-free. So anybody out here in this region out here gets what's called the penumbral eclipse, which is a bite taken out of the sun. Now, that may not seem very exciting, but how often have you seen a bite taken out of the sun? It's pretty cool to see that. It looks like a little Pac-Man feature to some degree. So we'll get that in Crystal Lake here, but way more than this. We're going to get about 85% of the sun with a big bite taken out of it. That's really cool. So anybody in the outer region called the penumbral portion will get what's called the penumbral eclipse, and they'll get a partial eclipse. Anybody in the middle portion, which is only a small part of the Earth because the moon doesn't have a huge shadow, will get the total eclipse down here. And it won't last more than 2 minutes and 40 seconds. So people are going to travel for hours and hours for 2 minutes and 40 seconds of glory. Imagine that. I'm going to drive potentially 8 hours or more just for 2.5 minutes. That sounds pretty crazy, but this is what you call a bucket list item. So, but what's weird about this is when this happens and the sun is out and the eclipse starts to happen, people in the shadow get to see it, but like other people not in the shadow, the sun will look normal to them. And simple as that. And so I want to show you what we would see potentially from Crystal Lake. So we'll even see more than this. This is an eclipse that happened a few years ago at sunset time. And look at the new moon. This is the new moon here, and it's going to block out the sun. And we're going to see only about 15% of the sun's face. And so, but what I want to see, the reason I'm leaving, I'm taking off the first day of school. I'm sorry about that, but I waited for this. I want to see this. Totality. You're going to have, in some places around the globe, across the United States, and this hasn't happened in the continental United States in 38 years, that we've had a total solar eclipse in our country in about 40 years. So 38 years we haven't had a total solar eclipse. So in here, you're looking at the new moon. That's not the sun, that's the new moon. But the cool thing is, when the new moon happens, the new moon blocks the sun during a total solar eclipse, you're blocking out the entire sun's surface. So what you see out here, that's what we call the atmosphere. That's the corona of the sun, the outer atmosphere. And so you never get to see that except during a total solar eclipse. So the cool thing is when you have your special glasses, and here's some glasses here, I'll show you. I think Student Life here at MCC is going to have a couple hundred of these, and these safety glasses will allow you to look at the sun, and you potentially should be able to even see some of the corona. And these are pretty stylish looking items here, but obviously they're there for your protection, so please keep them on during any sort of viewing opportunities. But this is never visible except during a total solar eclipse. So scientists really get excited about this because the only time they really get to study the outer atmosphere of the sun is during an eclipse. You get 2 to at most 7 minutes to actually to study the outer atmosphere. Now, today's techniques, we have filters to block out the sun, but in the past, they didn't have that ability. So they only had a few minutes to look at the sun in its grandeur. And so this is what I'm going to see. I'm looking to see this, again, barring any clouds. So to give you an idea just how exciting this is, let me show you what this would look like if for some reason you miss it and you don't get to travel like I'm traveling south. I'm going to show you an animation here of what a solar eclipse would look like. This is an eclipse happened a few years ago, and what you see is the new moon taking a bite out of the sun. Now we're going to see this, and if I'm not mistaken, here in Crystal Lake, and I'll open up the app to show you this, this happens a little after 11 o'clock in the morning. So we start getting a bite taken out a little after 11 o'clock. I'll give you precise times in a second here. And then by the time about 1:20, we get the full total extent, and then it ends sometime in the late afternoon, 3:30 or so. So it's going to be a several-hour event, but the best time is about 1:20 p.m. So as I advance this thing through, the cool thing about this is watch this bite of the new moon. Again, this is what we call the penumbral eclipse. Most people will see this. They'll see the penumbral phase, including us. But we're going to see more of it. We're going to see just about, and I'll stop it just for about how much we'll see, right about there. That's about how much the eclipse we'll see. About 85% of the sun's disk will be covered by the new moon. That's pretty awesome. So what's going to happen when that happens, it's going to get darker outside, obviously. It's actually going to get a little bit cooler. So it'd be kind of neat if somebody back here would take some temperatures and see what the temperature would drop to by blocking out the sun. You won't see stars, but if you go to a place with total eclipse, you'll see stars in the middle of the day. How cool is that? But you'll be like twilight time for a few minutes. And it'll be a very impressive display. Let's hope for a cloud-free up here. But I want to show you something really cool that happens during totality. And I'm going to stop this right before totality, because this is a really big deal. Right when the moon covers up the sun, at the point of just before it gets to the point of covering the entire disk, you get what's called the famous diamond ring effect. That's what I want to see. So I always tease my students. I say, guys, you know how you get married and you have to propose and you have a diamond ring? This is the cheapest diamond ring you're ever going to have. You have a chance to propose to somebody with a diamond ring that's bigger than any diamond ring you can imagine for free, right? Just don't screw it up. So here's what happens. It's covering up the new moon. Here it comes. I'll stop it. There's your band ring. There's your big diamond. That's your diamond ring effect. That's what I'm going for. So the cool thing is, what I'm going for is 2.5 minutes of glory to watch this total coverage. And what you'll see in the animation here is all of a sudden, complete coverage. I get 2 minutes and 40 seconds of that at best, where I'm heading, along with millions of other people. And then all of a sudden, out comes the corona. The beautiful corona will expand out. But here's the funny thing. Let's just say you were taking my advice and you were going to like propose to somebody on this day, and you got too scared and too nervous, and you go, I screwed up. I missed it. Well, not necessarily, because when 2.5 minutes later, when it starts to leave, you get the diamond ring on the other side. So you have a second chance. Then as we start leaving the eclipse, about 2.5 minutes later, there's your diamond ring again. Your chance to not screw up. That's your free chance for a free diamond, right? If not, you can always pay several $1,000s for a regular diamond ring. But as this thing advances through, though, again, the whole process is going to take like 5 hours for us to go from partial to maximum extent to partial again. And I want to show you where this is happening. I'll stop it there because you get the idea what's going to happen here. It's going to run off to the end, and I'll give you an idea where the event will be maximized. So let me show you first what it will look like here in Crystal Lake, Chicagoland region. This will be our eclipse. So here it happens. Here's our eclipse. Got to play it. There we go. The new moon will block out a substantial portion of the actual sun. Not all of it, maximum eclipse. And then it will roll off. But the entire process will take several hours to get through this. And it will be a pretty cool event to see. And I wish I was here with you, but you know what? I'll explain how you have another chance in case this fails us this year with clouds or what have you. So let me show you who gets to see it. The eclipse, not that one. This one. This is a map from Google Maps. And you can see anybody within this narrow band, in between the blue bands, and I'll zoom in for you. Anybody in between the blue bands, or purple, whatever color you think that is, gets to see the total solar eclipse. The start of the eclipse occurs at about 11:52 in the morning. It gets maximum about 1:18 or 1:20 or so p.m. and then it ends about 2:40 in the afternoon. So that's our total eclipse. So, but if for some reason this is cloudy or rainy or something, or you don't get a chance to go see it, there's some hope. You get 7 years again, the next good one. And here's the next one. In April, what's the date again? April 8th, 2024. So if some reason it screws up, anybody within this zone right here will get to see totality again. Again, Southern Illinois. I'm not sure what the connection is with them and getting the solar eclipses, but they seem to be lucky. But for us, we got to travel south again. But this one will be a little bit closer to us, just central Indiana to go to if you want to go see the total eclipse. But in April of 2024, 7 years from now, you have another chance to see an eclipse. So I'd recommend you go out and enjoy yourself, be safe. If you can go out and look at the sun, use some glasses. It's really a truly big astronomical event. I've waited my whole life for this, and if I screwed up, I got 7 more years for another one. Enjoy the eclipse, guys.